Hello guys, this looks like an easy application of problem 7 and the methods we've been using before, making the series expansions. I have just written the result of problem 7, or the statement of problem 7, and we apply it to E4. And that means that E4, the derivative of E4 divided by 2 pi I minus 4/12 E2 E4 is a modular form of weight 6. And we know they have to be proportional to E6 because the space of modular forms of weight 6 is one-dimensional. So it just needs to find the constant C. So we go back to the expansions. E4 equals there we go. The derivative of E4, the first term is 240 2pi divided by 2 pi I q minus 1/3, and I just need to check E2, I remembered it correctly. E2, that's 1 minus 24q times 1 plus 240q. And we just do the first two terms, 240q minus 1/3 well, it's 1/3 times 1, and then 1/3 24q times 1, that's plus 8q minus 80q so it's minus 1/3, 168. That's really weird, but let's take 1/3 out of the equation, rather minus 1/3, 1 minus, and 3 times this gives 504q. So we have confirmation that it's minus 1/3 times E6. Well. We will be verifying this in B, so that I get a wrong result I don't take too seriously. We'll just go on with E8. Now we apply the same formula to E6. The derivative of E6 divided by 2 pi I minus 1/2 E2 times E6. This is a modular form of weight 8. So this gives minus 504 just go back here. E6 differentiated minus 504 times 2 pi divided by 2 pi. That gives, that's it. Then minus 1/2. Let's just take the first term. That's enough for the proof, and we'll get the next term in part B. And E6 giving 1. This is really weird. So it's minus 504 minus, so it's minus 1009 halves. We are nowhere near the 480. Oops. This is of course times Q. So it's just minus 1/2 plus something times Q. So it's equal to some constant times 1 minus etc. So we can easily see that C equals minus 1/2. Or I'll just write up the result here. So that's E6 divided by pi I minus E2 E6 equals E8. It was a minus, so it's minus and plus. And now up here it was minus 1/3. So that means this equals 1/3 E6 so first this cancels, and then this is 3 divided by 2 pi I. And I hope this is exactly part A. E6 equals, damn it, I have the wrong sign. And E8, I have the right sign. So what did I do wrong here? This should be minus 3, oops, minus 1/3 x6. So we change the signs here. That seems to be that. In the timeout, I wrote up E6, E4, E2, and the derivative q mark, it gets n, q to n minus first q mark, and q mark, it's 2pi times q, so that's eaten, and then 3 times 240, that gives 720. And the same over here, E8 copied, E6 copied, E2 copied, and the same. It gives 2 times the coefficient to E6, which was 504, so it gives 1008. So we expand. Let's put this on the other side. So everything equals naught. Oh, we should have let's keep it, because we need to isolate sigma 5 anyway. And then 1, which we cancelled, 240, sigma 3 of n, q, let's write the q to nth, minus 24, sigma 1, and 24 squared, that's 576, I believe. And we know that we can collect this to the sum of the terms. And it cannot be equal to m because the n's here must be larger than or equal to unity. And then minus 720. Ooh. N sigma 3 of n q to nth. So collecting the terms, minus 540 sigma 5 of n equals 240 sigma 3 of n minus 24 sigma 1 of n minus 720 n sigma 3 of n, they can be collected, minus 5,700. Why did I do that? We have to divide by 504. I don't know what that gives. The sum of sigma 3. Oh, I should just, no, that's the star product in number theory means something else. This is just a sum here. And we do the same here. I won't use your time, so I'll just pause, do it, and then I will check it in Maple and show you the result.